Capacitor with a dielectric problem. A parallel plate capacitor can store up to 3.24 times 10 to the minus 10 coulombs of charge on each plate when connected to a 9-volt battery. The capacitor has a plate separation of 0.25 millimeters. A. What is the area of the plates? B. What is the electric field between the plates? And C. Calculate the stored energy on the capacitor. We now insert a dielectric material with kappa equal 4.0. Recalculate the new net electric field. Does the electric field increase or decrease with the dielectric? Why? Calculate the new capacitance and energy able to be stored on the capacitor. We've got our givens up here at the top, and we need to find the area of the plates. We're going to combine the two capacitance equations. Right? This one depends on the battery. This one depends on the physical configuration of the capacitor. And we get Q over V equals epsilon 0 A over D. Now we want to find A, so we have to solve that equation for A by multiplying both sides by D and dividing by epsilon 0. And we now have the area. Now we just plug in the givens. Here's our charge. Here's the distance between the plates. Here's the voltage supplied, and here's the permittivity, and we get 0.001 square meters. What is the electric field between the plates? So we're going to use the electric field equation here. We won't put the minus because that just gives us the direction of the electric field. We just want to know the magnitude. X is the distance between the plates, which is the same as D, which was in our givens. So the electric field is 9 volts over 0.25 times 10 to the minus 3 meters. Carry out the math, and you get an electric field of 36,000 volts per meter. Now remember, please, electric field is also written in newtons per coulomb. Both are equivalent. Now calculate the stored energy on the capacitor. Well, we have our energy in a capacitor equation, 1/2 QV. We're given Q and we're given V. So that's the one we're going to use, and we get the potential energy, or the energy stored in the capacitor, is 1.458 times 10 to the minus 9 joules. We've now added a dielectric, and what the dielectric does, it reduces the net, the total electric field, by a factor of kappa. So E net is going to be E0 over kappa. We have our electric field calculated from the previous slide, 36,000 volts per meter. Divide that by 4 and get 9,000 volts per meter. Now here's the key point. The dielectric does not change the field produced by the battery. That's the same, but it creates a new electric field in the opposite direction so that the sum of these two, which is the net electric field, is reduced by kappa. And that's what we have right over there. Does the electric field increase or decrease with the dielectric, and why? The initial electric field, E0, is created by the battery, and that stays the same. That doesn't change at all. When the dielectric is added, a second electric field, E dielectric, that's this over here, is formed due to the alignment of the dielectric molecules, and it's in the opposite direction. So when you add these two fields together, you get a smaller net field. Now we're going to find the new capacitance and the energy that is able to be stored on the new capacitor. So we start with the equation for capacitance with the dielectric, where kappa is a dielectric constant. We substitute in our givens. Here's a dielectric constant, here's epsilon 0, cross-sectional area of the plates, and here's the distance between the plates. We get a new capacitance of 1.416 times 10 to the minus 10 farads. We're going to use the energy equation with C and V. V stays the same. We have the same battery, and the capacitor is still hooked up to it. And we have a new capacitance that we calculated on the previous slide. So we plug that new capacitance in. We have our voltage. Again, make sure you remember to square it. We get a new energy storage of 5.73 times 10 to the minus 9 joules. Now, do not use an energy equation with Q in it, because the charge stored on the plates changes when the dielectric is added, and we never calculated the new charge. So this is the right guy to go to.